Kevin, and this is a printer, and so
when he came to me, he was asking me, "Hey, Mr. Tian, all these projects I've done, I'm bored with them. What's something that is really challenging?" And we talked with each other for a little bit, and he came up with, "Hey, how about a 3D printer?" I'm saying, "Yeah, why not? We'll build it out of Lego." So we did some research, meaning we both did research on how we can build the different axes. Can you talk a little bit about how a 3D printer works?
Yeah, so there's an X, Y, and Z axis. My goal was to build a 3D printer, but I couldn't because the Z axis was complicated. So it does actually kind of make 3D objects, but that's because of the properties of the glue. And also, so the X axis is left and right, the Y axis is forward and backward, and the Z axis is height. So it's length, width, and height to make a 3D object. So usually, like in the real world, you would get a 3D printer and you would like design your object and then you would make it print, and that's how they work. So it usually requires a bunch of different motors called stepper motors. And I also use motors, but these are not really stepper motors. So yeah. Okay. And I also I also use static parts, which are parts that are not likely to move, which are the beams, axle beams, and these pegs and technical blocks. And my dynamic parts, which are parts likely to move, is an axle. In this case, it's not really moving, and bushings, and a flexible axle connector for friction, so it could get it to be a higher height.
And then, so a couple more things that we do want to talk about is the electronic parts on the robot, right? So electronics are parts that run on electricity and information. So what are those parts on our project?
Motors, wires, EV3, controller brick, and also, in this case, usually we wouldn't use this, but the glue gun is kind of electronic because it's sending electricity to it so it could heat it up and melt the glue.
Kevin, what is EV3? Because I don't know anything about it.
EV3 is it's Mindstorm. So Mindstorms is how you control something. It's like a set.
So when we talked about, first he was enrolled in an NXT, but for this project here, after doing a lot of research, we found out that it's a lot easier for us to use an EV3 because of the time constraint that we had. We only had 4 weeks to work on this project. So we went ahead and upgraded them to EV3 in order to use all the parts that they do offer. So it's a microcontroller. That's how we're able to do it. And then next up, we do want to talk a little bit about our process of how we got into this, our design, our RSDLC. Okay.
Okay. So we first play. We put goals, not play. Play is the last thing. So we went online and did a little bit of research, and this is what we thought about first. So our print space would be down here. The X and Y axis would move that way and this way. And then the Z axis was here, which we didn't include because we didn't have as much as time, and it was a hassle to build the contraption. And then it would come down. And we went to this is our second process. So we had a support here, counterweight, and the x-axis is here, and the y-axis is there, and that's the print space. Also, on the y-axis is where our print space is on that, too.
What about our last version there? So we got one more here that we do want to show you guys. Sorry about the bad art.
And this is our printer that we call it. And this is our EV3. The y-axis, the y-axis is here, the x-axis is here. Then the sturdy cage is how this contraption is.
So what's the point of having that?
Because we needed to have it to be leveled. Because if it was all not sturdy, then it would be all over the place, and you couldn't really hold the trigger anyway, and to push the glue in. And and these are our first prints. So we have a kind of failed print because the lines weren't thick and you need a consistent of lines. Then that was slow down. That I don't know what happened. That shape is kind of good, and this is too thin.
How do we fix when we're
And we made it more sturdy, as I said, and we added this with the help of
Alfonso.
And then this is another print, and we need another motor. So we couldn't do that because that was like 30 minutes before our like not open house, like end of my class. So I couldn't really what I would do is probably put gears to push this down, or like a thing to push this up immediately when it starts. And we didn't have enough time to program it either.
We did.
Well, we did program this, but we didn't program, we wouldn't have time enough to program the other contraption. And that's another print, and that's I don't know what happened there, but it's still the lines were kind of too thin because you have to have the glue be able to stay consistent. Usually right when you push it, it's trying to burst out, so then it doesn't really inside of it there's a bunch of parts that work together. So yeah, and then one of our best prints was this one and this one, but it's kind of still small. So yeah.
You did build what our program? What did you do for the
I
program?
programmed it so that first the A motor, which is the y-axis motor, would go forward. This would go backward. This would go forward, and this would go backward to make a square that I wanted to demonstrate. But you could, afterward, you could have it do whatever you want. So you can have one here go forward a little bit. You could make this, and you can have a 3D object. So that's how 3D printer works, which is you need at least 2 layers or more, but this is 1 layer. It looks 3D, but it doesn't actually. It's kind of 3D and not 3D. But so it would create. It would do that, the 1 layer, then on top of it, that's how real 3D printers work. It would create another layer.
Multiple layers, right?
Yeah, and then another, and so on and so on.
All right, very good. So you want to demonstrate your project here after?
Wait, I didn't touch that.
Let's talk about this.
So the touch sensor is to wait until my command. So this kind of makes it easier because I need to be press it and then quickly hold the trigger for the glue gun. So I can give it to someone and say ready, 3, 2, 1, and then push it. And then also in the programming you have to put weight blocks. There's different blocks, move blocks, weight blocks. That's what control these. And
that's it. I think we're ready to demonstrate our little printer here. Let's show it this way so everybody can see. You want to?
Okay.
Might hold it?
Do you want to pull the trigger?
Okay, I'll pull the trigger. So let me go here so you guys can see it. Let's set it up the way that we want. Alrighty. Give me just a second.
Set, go. Whoops.
Oh, let's redo that. Gotta set it in the right starting position.
Oh.
Sorry about that. This way, right?
Yeah.
There we go. Alright. There you go. Go ahead. Press it. Oh, I didn't start, sorry. Let's get into that. That's why we went through a lot of trials, because we were constantly fine-tuning our project and troubleshooting it.
It's just more post-it notes for the wall.
Exactly. Alright, so let's start our program here. Oh, not this one. Start our program here, this one. There we go. Alright, here we go.
Okay, ready? 3, 2, 1. Oh, that didn't work.
the other program, sorry. A lot of fine tuning coming into these technology. Alright, here we go.
3D printers are new, so it's not like.
They're not so new, but they're kind of
Well,
new.
they're starting to be.
Alright, here we go.
For cheaper.
Try it out.
It's not even.
It's okay.
Okay. Okay, so we created a rectangle, a blobby rectangle.
You want to show off?
Okay, so now, wait. Okay, so, one second.
Okay.
Here's one for you, one for you, one for you.
So those were all the problems that we went through, and we made notes on it. I made sure to make notes. So hey, we gotta slow down the motors there. Make sure that there is enough time for the glue gun to disperse some glue. What'd you have? Yeah, that one we didn't know what happened, so I was like, wait, what's going on here? So you definitely make notes so that when we come back and we look at it, I'm like, hey, how can we fix these problems? So that's a little bit of troubleshooting that I helped Kevin to go through. Oh, you wanna? Okay, I'll take care of this one.
Okay, questions.
Questions? Any questions?
First, I'd just like to say this is really awesome. I've made machine guns. My friends have made rattlesnakes using EV3 milestones, and and to be honest, this is one of my all-time favorites. It's just really awesome. And
Thank you.
Great.
I like asking this for these types of presentations. Is if you had 7 more days, what would you add to it to make it
I would
better?
definitely try and add a z-axis because I wanted to actually be a
We did add a z-axis.
We
Talk about what
did?
happened to our z-axis.
We did, but like we were trying to so we made a contraption with gears and it kind of used torque,
Yeah.
which is another whole different process
To pull it up and
to
down.
pull it up and down, and then so we had a string and we were trying to wrap it around here and it was a hassle. So I would do a z-axis if possible. Definitely.
You started out saying that you were a little bored and you were looking for a new challenge, and this is a very ambitious project. Was it kind of a fun challenge, even
Yeah,
though it was
it was
hard?
a fun challenge too.
It's awesome. It's great.
It is.
So can I say something?
Sure.
I think Kevan is dreaming 3D printer when he comes home until he goes from school to see
He's
them.
super excited.
I can see that. He's so passionate. He knows a lot about 3D printers now.
He has to do a lot of research for this project.
He has so much vocabulary he has gained through this process of learning.
I even know a bunch of other stuff of actual 3D printers like STL files and G code and like heated beds, stepper motors,
Very cool.
a bunch of other stuff.
Any more? Couple more questions.
Why were you giving out these?
I don't know. I
Samples of our work.
samples of
Our
beautiful stuff.
trial and error. Trial and error.
3D printers are like the new thing. Everybody's using them.
Yeah.
Somebody, Raspberry Pi
Right.
just started printing laptops.
You can
and
definitely do
people
that.
are 3D printing with chocolate and
Yeah, they're doing food
Yeah, they're
and
3D
sugar.
printing. Yeah.
And also, there's a lot of different technologies. You can have an Arduino code, and you can actually control stepper motors, which you could repeatedly make something. So you could have code of just filament going right in and just z-axis, and then you can make a loop with Arduino, and then you could put a Ram's board, which is another whole different process of real
We'll talk about that.
things, and also you need a bunch of engineering, technology, art, which I decorated kind of. It's not a really big decoration, but
I think it looks nice.
Yeah.
I'm proud of this.
It's just 3D printers are really popular now,
Right.
and it's good to see people from
Let's build a
Mathobotix
Lego one, right?
really starting to.
Do you know, in the medical field,
yeah,
they're trying to print a heart.
Yeah, heart valve.
Oh, so you know it. So he's done his
bladder,
homework.
kidney. They make a bunch of
Yeah.
weird stuff.
Bionic arms.
Yeah.
definitely.
Yeah.
Pi Top is the new
Yeah.
the new laptop Raspberry Pi.
Yeah, yeah,
It's green and it's
yeah.
really awesome.
Great job. Give him a big round of applause.